Got a question here from defining the derivative number 12. The function is s of t equals t squared minus 13, and we're supposed to find, for the first part, s of t plus h minus s of t all over h. So this is what we're after right here. And so I break it up and I look at s of t plus h and s of t. S of t plus h is t plus h squared minus 13 times t plus h. So t plus h squared is t squared plus 2th plus h squared. Then I distribute that 13, so minus 13 times t is minus 13t. Minus 13 times h is minus 13h. That's where we get this expression. So I bring it all together as s of t plus h minus s of t all over h. So this first part is my s of t plus h. And this second part is my s of t. And let me go back to blue now. So I need to, there we go. Okay, so we end up with a t squared plus 2th plus h squared minus 13t minus 13h. Distribute that negative, minus t squared plus 13t all over h. So what's interesting here is that anything without an h is going to go away. If it doesn't, we made a mistake. So the t squared subtracts out, the 13t subtracts out, and what we're left with is 2th plus h squared minus 13h all over h. And this is why everything needed to have an h, because that divides out, and gives us 2t plus h minus 13. So this is the expression we're looking for. Then the second part of the problem asks you to evaluate this at h being 0.1, h being 0.01, and h being 0.001. With t equaling 8, in the first case we're going to have 2 times 8 plus 0.1 minus 13. That's going to give us 16 minus 13 plus 0.1, so 3.1. In the second case, 2 times our t is still 8 plus 0.01 minus 13 will give us 3.01. And then in the fourth case, it's 2 times 8 plus 0.001 minus 13 gives us 3.001. And that's the problem. So now you go to the instantaneous velocity, you look at that trend, 3.1, 3.01, 3.001. So the instantaneous velocity, instantaneous, make sure I spell it correctly, velocity must be, well, looks like it's trending towards 3. And that's what you're supposed to do with that problem. Okay, hope that helps.